Hello everyone, my name is Mazyar Saraj and I'm going to present my poster entitled Learning and Practicing Logic Circuits, Development of a Mobile-Based Learning Prototype in CHI 2021. This poster provides a set of information about our new approach which enables computer science students to learn and practice the basics of logic circuits independently via their mobile devices. In computer science discipline, logic circuits is a basic topic. In this topic, the students learn about different types of logic gates, their functionalities, and the design of logic circuits using these logic gates. In this way, the students need to learn about the code, which is mostly based on hardware description languages like Verilog or VHDL, and learn about the graphical model of the circuit and truth tables and Boolean functions. To motivate the students to practice and learn more about logic circuits, researchers and educators take advantage of e-learning technologies. Different mobile and web-based applications have been designed and developed. These applications mostly help students to draw circuits and practice and learn more about truth tables, Boolean functions, and graphical model of logic circuits. Nevertheless, we still have lack of a practical learning system which enables students to learn also about the hardware description language which stands behind the graphical model of a circuit. Our approach is based on a mobile-based learning application to support independent practicing and learning in a blended learning environment. So it's designed to be used as a supplementary tool in addition to the face-to-face classrooms. The mobile-based learning application is divided into three main sections, namely tutorial, practice, and evaluation. In each section, multiple representations of logic circuits are included to foster understanding and transfer. More importantly, we tended to show the potential value of the implementation of the 4CID instructional model into mobile-based learning environments. It might be a question that how the learning system works in an educational setting. In our learning system, instructors write a piece of Verilog code which represents a logic circuit and upload it into the system. Then the system starts parsing the code and shows it in the output at the same time. Then the system starts drawing the graphical model of the circuit based on the Verilog code, type of gates, number of connections, number of inputs, outputs, and gates. Also, when the student taps on a gate in the graphical model or a line of code, the system shows the truth table and the Boolean function corresponds to that particular gate. In the next two slides, I would like to show some screenshots of our mobile-based learning prototype. These are the three sections in our prototype, namely tutorial, practice, and evaluation. In the evaluation section, we take out the truth table and Boolean function to make the task more challenging for our students. This slide includes more information regarding the evaluation section and the final hints based on the inputs and connections which are chosen by students. As we are in the earlier stage, this work is still under an ongoing development and maintenance, so there are several pathways of future work. The technical aspects and the application user interface need to be improved and modified. A major concern for future work is to investigate the impacts of the mobile-based learning system on students' learning outcomes and on their attitudes towards hardware description languages. To provide more examples, we aim to store Verilog codes and make new and meaningful examples from the stored data. While several studies indicate the benefits of multiple representations for learning outcomes, the issue of how to combine them to support learners to integrate them in one coherent mental model is of major importance. So it's an interesting approach for the future iterations of this work. Comparing the mobile-based learning system with web-based environments can be another pathway of future work to evaluate a student's performance and attitude towards self-learning and self-practice in the context of hardware description languages. Thanks for your attention. Stay safe, and I hope to see you all during my poster presentation this year at CHI.